Lesson 8.7, Factoring Special Cases. The objective of this lesson is to factor perfect squared trinomials and the difference of two squares. Vocabulary. Perfect squared trinomial. Any trinomial of the form a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. A squared plus 2ab plus b squared can be factored as a plus b quantity squared. Example, x squared plus 8x plus 16 equals x plus 4 times x plus 4, which is equivalent to x plus 4 quantity squared. A squared minus 2ab plus b squared can be factored as a minus b quantity squared. For example, 4n squared minus 12n plus 9 equals 2n minus 3 times 2n minus 3, which is equivalent to 2n minus 3 quantity squared. The difference of two squares. A difference of two squares is an expression of the form a squared minus b squared. It can be factored as a plus b times a minus b. Perfect square trinomials. You can factor some trinomials by reversing the rules for multiplying special case binomials that you learned in lesson 8.4. For example, recall the rules for finding squares of binomials. A plus b quantity squared equals a plus b times a plus b, which is equal to a squared plus 2a plus 2 plus b squared. We did this in lesson 8.4, so this is just a review. In this lesson, we're working backwards. We're going to be given a squared plus 2ab plus b squared, and we're going to be asked to factor it, and the answers are going to look like this. Any trinomial of the form a squared plus 2ab plus b squared or a squared minus 2ab plus b squared is a perfect square trinomial because it is the result of squaring a binomial. Here's how to recognize a perfect square trinomial. The first and last terms are perfect squares. The middle term is twice the product of one factor from the first term and one factor from the last term. Factoring perfect square trinomials. Problem 1. What is the factored form of x squared minus 12x plus 36? First, let's see if the first term and the last term are perfect squares. X squared and 36 are perfect squares. So we can write the last term as a perfect square because the first term is already written as a square. So we can write 36 as 6 squared. So then we have to ask, does the middle term equal negative 2 times a times b? Negative 12x equals negative 2 times x, which is a, times 6, which is b. So is that equal to negative 12x? That is. So our final answer is x minus 6 quantity squared. We're doing minus because the original problem had minus. Problem 2. What is the factored form of 4x squared plus 20x plus 25? We're going to write the first and last terms as squares. 4x squared can be written as 2x quantity squared, and 25 can be written as 5 squared. So 2x quantity squared plus 2 times a, which is 2x, times b, which is 5, plus 5 squared. Double check that the middle term equals 20x, which it does. So your final answer is 2x plus 5 quantity squared. Factoring a difference of two squares. Recall from lesson 8.4 that a plus b times a minus b is equal to a squared minus b squared. So you can factor a difference of two squares, a squared minus b squared, as a plus b times a minus b. Again, we're working backwards. Examples, x squared minus 64 is equal to x plus 8 times x minus 8. 25x squared minus 36 is equal to 5x plus 6 times 5x minus 6. Problem 3. What is the factored form of z squared minus 9? You can rewrite 9 as a squared, which is 3 squared. So your final answer is z plus 3 times z minus 3. We're going to factor using the rule for a difference of two squares. Problem 4. What is the factored form of 16x squared minus 81? Here we're going to rewrite each term as a square. 16x squared can be written as 4x quantity squared, and 81 can be written as 9 squared. Therefore, our final answer is 4x minus 9 times 4x plus 9. Again, we are using the rule for the difference of squares. Factoring out a common factor. When you factor out the GCF of a polynomial, sometimes the expression that remains is a perfect square trinomial or the difference of two squares. You can then factor this expression further using the rules from this lesson. Problem 5. What is the factored form of 24g squared minus 6? The first thing you always look for is the GCF. In this case, there is one. The GCF is 6. When we factor out 6, we're left with 4g squared minus 1. Now, there are only two terms in here, so we have to think, is this a difference of squares? If it's not, then this would be your final answer. If it is, then you use the rule for difference of squares and you keep going. In this case, this is the difference of squares. So we're going to write 4g squared as 2g quantity squared, and we're going to write the number 1 as 1 squared. Therefore, the final answer is 6. Bring down the 6. Remember, the GCF just comes along for the ride. 2g plus 1 times 2g minus 1. We use the rule for the difference of squares for what was left over after we factored out the GCF. Now let's do a few together. What is the factored form of x squared minus 14x plus 49? First thing you got to look at is how many terms are here. We have 3 terms, so it's definitely not difference of squares. We're going to look at if it's the other one. Sorry, I had a little brain fart. X squared minus 14x plus 49. The first term is a perfect square. The last term is a perfect square. You look at the sign of the middle term. So it's minus. So we're going to have square root of the first term, which is x, sign of the middle term, which is minus, square root of the third term, square root of 49 is 7, quantity squared. Number 2, what is the factored form of 25d squared minus 64? Here we only have 2 terms, so the only possible special case that it could be is difference of squares. Now we need to make sure that 25d squared can be written as a square. Well, square root of 25 is 5, the square root of d is d, so we can write that as 5d quantity squared, and we can rewrite 64 as 8 squared. We're going to use the rule for difference of squares, so the final answer is going to be 5d minus 8 times 5d plus 8. Boom. Let's look at one more. We have, what is the factored form of 12t squared minus 48? Remember, when you're factoring, the first thing you want to look for is the GCF. Here I see that 12 is also a factor of 48. So my GCF is 12. So let's factor out. If I factor out of 12, I'm left with t squared minus 4. Now, I don't care about this 12 anymore. I'm looking at what's inside parentheses. Now, there's only 2 terms in here. So the only thing I have to look at is this a difference of squares? In this case, it is. So I keep going. All I do is I bring down the 12. The square root of t squared is t, and the square root of 4 is 2. So I'm going to have t minus 2 times t plus 2. And that's my final answer. Again, once you factor out the GCF, you look at what's inside parentheses and you try to factor that further, if you can. If you can't, then all you have to do is factor out the GCF and you stop. If you can, then you keep going and the GCF just comes along for the ride until you get to the final answer.